I'm Dr. Adam Tiemann, a faculty member at Bar Ilan University, and I'm also a co-director of the SoC Lab in the ENICS labs at Bar Ilan University.
Hi, I'm Yonatan Shoshan. I'm the design manager in ENICS SoC Lab. I lead a team of engineers responsible for the design of SoCs all the way from RTL to GDS2 tapeout.
The HiPer Consortium is a consortium that was started by the Israeli Innovation Authority about 5 years ago and includes all the big IC companies in Israel: Mellanox, Ceva, DSP Group, Satixfy, Ceragon. In the past, we also had companies such as EasyChip that was bought by Mellanox and Altair that was bought by Sony. In the HiPer Consortium, we've been researching high performance, that's HiPer, system on chip design, and a special entity was started inside Bar Ilan University, a team of engineers inside an academic environment. We call it the SoC Lab, the SoC Lab, and that's what I'm a co-director of. And we have designed at the SoC Lab 2 chips. The last one just came out a few months ago. It's a 16 nanometer FinFET big chip that was made inside a totally academic environment, and it includes all kinds of innovation that was done within the consortium and within the academic partners inside the consortium.
We recently taped out an SoC in TSMC's 16 nanometer FFC. It's your normal SoC, about 11.5 millimeters square. It consists of 4 DSP cores by Ceva, a complex interconnect by Sonics, several different interfaces, fast Ethernet, slow UART, and I2C, and so on. Of course, we have memories, but the main idea is innovative technology embedded in it as a proof of concept, such as embedded DRAM, a thermal sensor, and other innovative technologies. It's been done in collaboration with research groups from Bar Ilan University and others, and companies from the industry such as Mellanox, Ceragon, Ceva DSP, Cadence, and TSMC. It's one of the most complex designs ever done in an academic environment. As technology advances, so does the complexity, which for DRC means that there are so many more rules. That requires the EDA tool to scale, hopefully the same as the growth in DRC rules. Unfortunately, this is not the case most of the times. That means runtime gets much longer, and this is a big issue for the designer. In addition, we have to use higher-end machines with more memory and more CPU time. We have to reserve them in advance, and this causes issues, so we have to deal with that. So Pegasus is the newest tool from Cadence doing DRC. The big thing about Pegasus is that it offers linear scalability. That means if I'm adding more CPUs, I get a linear speedup. So for example, on our design, if to run a full DRC would take more than 7 hours, if we add more CPUs, we could get as good as 1.5 hours. That means that instead of having an overnight runtime, we can do it over lunch. That means we can have multiple runs during a day with the fixes and so on, and obviously we get a big improvement by that. We used Pegasus in our recent project and helped us in many ways. It improved runtime, and in addition, we used QuickView to improve our flow, and it helped us to get to tapeout on time.